Alright, in this video I've got 3 short examples of factoring. The first one that we're going to do is factoring with a common monomial. And you might also know this as greatest common factor. Let's write that up there. Greatest common factor. So here's a polynomial, and the first thing I want to look for are greatest common factors. So between a 25, 75, and 5, a greatest common factor is a 5. Between the x squared, x cubed, and x, the greatest common factor is an x. And that's all I can factor out because this last term doesn't have any y's. So what are we left with? Well, 25 divided by 5 is 5. X squared divided by x is x. And we didn't factor out a y, so we still have the y. Moving on to the next term, 75 divided by 5 is 3. X cubed, factoring out an x or dividing out an x, we're left with an x squared. And since I factored out the 5 and the x, 5x divided by 5x is 1. So there's an example of factoring using the common monomial or greatest common factor. All right, let's do another one now. This is on grouping. And here's a polynomial, and I'm going to factor this by grouping. So the first thing I want to do is I want to kind of think of these as two separate groups. So I'm just going to kind of spread this out a little bit just to help me visualize that I have two separate groups there. So once I've separated it into two separate groups, I'm going to look at each group kind of separately. And when I do that, I'm going to think about greatest common factors. So I have a 15 and a 6. A greatest common factor is a 3. I have an x squared, an x cubed and an x squared. A greatest common factor is an x squared. Well, what am I left with in this little group when I factor out a 3x squared? I'm left with a 5, because 15 divided by 3 is 5. And x cubed divided by x squared is x. And then 6 divided by 3 is a 2. And I had an x squared, and I factored out an x squared, so the x's are gone. Let's take a look at the second little group here. So I have a 10x and a 4. The greatest common factor is a 2. And that's all I can take out because this last term doesn't have any x's. So when I figure out what I have left here, 10 divided by 2 is 5. And I still have that x because I didn't factor any x's out. And then 4 divided by 2 is 2. And if I've done this successfully, you will notice that this group here and this group here are the same. That's kind of the whole goal of factoring by grouping. So then I'm going to take and write that common group right here. It's kind of like I'm factoring out the common group from each one of these factors. So what am I left with? Well, I'm left with this piece right here, 3x squared, and I'm left with this piece right here, plus 2. And that's how you factor this cubic right here by grouping. All right, and let's do one more. Let's do the difference of two squares. This is a really handy technique here. 81 is a perfect square, 9 times 9. 25 is a perfect square, 5 times 5. And x to the 4th, well, I can think of my x to the 4th as x squared squared. Right? Remember when you have an exponent to an exponent, you multiply? So this is a perfect square. It's x squared squared. So when I figure out that I can use the difference of two squares, and by the way, difference means subtraction, the way I do this is I just start by writing my two empty binomial brackets, and then I say 81. What's the square root of 81? That's a 9. So this one gets a 9, this one gets a 9. X to the 4th. Well, remember I can think of that as x squared squared. So the square root of that, well, x squared goes here, and an x squared goes here. 25, the square root of 25 is 5. A 5 goes here, and a 5 goes here. And then one of the binomials gets a minus, one of the binomials gets a plus. And that's how you factor the difference of two squares.